Hello everybody, welcome into another lesson. So today we are going to talk about inscribed angles and circles. So far we've talked about central angles, where in a central angle, if we remember by the definition of that, the vertex of that angle is at the center of the circle, and then the sides of the angle are radii of the circle. Well, here we have a circle with an inscribed angle. An inscribed angle in a circle has the vertex on the circle itself. It's on the circle, and then the sides of the angle are chords in a circle. So then we have arc AB, which has a measure of 140 degrees. Well, this theorem tells us that the measure of an inscribed angle is equal to half the measure of the intercepted arc. So we have angle 1 here, the inscribed angle in this circle. To find the measure of angle 1, you would just take half the measure of arc AB, which is half of 140 degrees, which then means the measure of inscribed angle 1 is 70 degrees. Really quite simple. Now I'm going to keep this circle here. We're going to do a corollary based on this. There is a corollary here for this. There's actually a few corollaries for inscribed angles, and then there's another theorem. Alright, let me just set up a quick illustration here, alright? This will be... Alright, so this time we have a circle with two inscribed angles, but they both touch the same arc. Well, this corollary states that if two inscribed angles intercept the same arc, then the angles are congruent. Well, we've already established that the measure of angle 1 is 70 degrees, right? Because it's half the measure of the intercepted arc. But if you look at inscribed angle 2, it also intercepts arc AB. So that means the measure of angle 2 would also equal 70 degrees. Therefore, we can say that angle 1 is congruent to angle 2. Since they're both 70 degrees, they are both congruent since they intercept the same arc. Alright. Next, let's see. Set up another illustration here. All right. So this corollary tells us that an inscribed angle in a semicircle is a right angle. Well, let's think about this here, right? A circle has a measure of 360 degrees, right? So that means a semicircle, half a circle, is 180 degrees. So we know an inscribed angle is equal to half the measure of the arc it intercepts. If it intercepts a 180 degree angle, that would make sense then that it's a that the inscribed angle is 90 degrees. So the measure of angle 1 would be equal to 90 degrees then, since it intercepts a 180 degree angle. That actually makes a lot of sense. Alright, one more corollary, then another theorem. Then we're going to do some exercises. There will be 9 exercises today that are very useful. Alright, do the circle. Alright. Okay, so here we have a circle with a quadrilateral inscribed in it. And again, on inscribed polygons in general, each vertex of the polygon has to touch the circle itself. Not be inside the circle, but touch the circle itself. This corollary tells us that if a quadrilateral is inscribed in a circle, then the opposite angles are supplementary. So what does that mean then? Supplementary angles add up to 180 degrees. So if you take A and C, those are opposite angles. Take the measure of angle A plus the measure of angle C, you would come up with 180 degrees. And then likewise, if you did the same with B and D, those are opposite angles, they're going to be supplementary. So the measure of angle B plus the measure of angle D would also equal 180 degrees. So that is what this corollary states about quadrilaterals inscribed inside of a circle. Then there's one more theorem. It's about another type of inscribed angle, but it's a little bit different from what we've done so far. You'll see just how different in a second. All right. actually, let's change that a little bit here, huh? Alright, so in this circle, we have an angle, we have an inscribed angle. Of course, the vertex is still on the circle. But one side of the angle is a chord of the circle, the other side of the angle is a tangent line to the circle. This theorem rather tells us that an inscribed angle formed by a chord, not a choroid, what the heck is a choroid? Boy, oh boy, if I could spell, that would be just great. Maybe I need to take English class again. An inscribed angle formed by a chord and a tangent line is equal to half of the measure of the intercepted arc. So we have angle ABC formed by chord AB and tangent line BC. This is telling us here that the measure of angle ABC is going to be equal to half the measure of the intercepted arc, which would be AB. That would be arc AB. Which arc AB has a measure of 140 degrees. So that'd be half of 140 degrees, which means the measure of angle ABC then would equal 70 degrees. Since it's half the measure of the intercepted arc, measure of angle ABC would end up being 70 degrees. And then now we're about to do some exercises to put everything we've learned today into practice. There are 9 exercises. We're going to solve for some variables, x, y, and z. Let me get to the page, that would help. All right. Alright, so we got a circle here. We can clearly see the diameter here through the center O. And then you have to solve for x, y, and z. Well, the good news is everything occurs in the top semicircle, right? A semicircle has a total arc measure of what? 180 degrees. So let's solve for x first. If the 100 plus x plus 50 have a combined measure of 180 degrees, it's going to be easy to solve for x. Just take your x plus your 50 plus 100, set that equal to 180 degrees, since that's the measure of a semicircle, which would then give you that x plus 150 degrees equals 180 degrees, which means what? That x would equal 30 degrees. So the arc measure for the x degrees is 30 degrees. Now we can solve for y and z. Let's solve for y. We know that an inscribed angle is half the measure of the arc it intercepts, so y is going to be equal to half of 50 degrees, since it intercepts that arc. So y would be equal to 25 degrees. And then last but not least, we got to look for z. Well, we already found x to be 30 degrees. Since z is an inscribed angle and intercepts a 30-degree angle, that means z is going to be half of 30, which means z would be equal to 15 degrees then. So what you should get is that x would equal 30 degrees, y is 25 degrees, and z is 15 degrees. Next problem. All right, we have, this is x degrees, y degrees, and z degrees. All right, so we have 60 here, 65 here. We don't know that one, but that's okay. All right. So this time we have a circle with an inscribed triangle. We have, of course, a triangle with two angle measures of 60, 65, and then we got to solve for all the arc measures of x, y, and z. Let's look at x here first. We notice that the 65-degree angle here, that inscribed angle, intercepts the x degrees. So if an inscribed angle is equal to half of the intercepted arc, that means to find the intercepted arc, it would be twice the value of the inscribed angle. So x would be equal to 2 times 65 degrees, which would have to mean that x is equal to 130 degrees. So that arc has 130 degrees. Let's go to y. Y, of course, the 60-degree inscribed angle intercepts the y-degree arc. So, again, to find the arc, you're going to take twice the inscribed angle. So y would be equal to 2 times 60 degrees, which of course would have to mean that y is 120 degrees. So we have x at 130, y at 120. So we can solve for z quite easily now. We know the measure of the arcs of a circle is 360 degrees. So take your x value of 130 plus your y value of 120 plus your z, which we don't know, set that all equal to 360 degrees. Which then means you would get z plus 250 degrees is equal to 360 degrees, which would then have to mean that z is equal to 110 degrees. So x would be 130 degrees, y is 120 degrees, z is 110 degrees. That's what you should get. right, we got a quadrilateral here. X degrees, Y degrees. We got 80, 70. This arc is 120. Then we need to find this arc here being Z degrees. Alright, so we have a quadrilateral inscribed in the circle with an arc measure at the bottom of 120. Then we got to solve for arc with Z degrees. Well, let's start with X. What do we know about quadrilaterals inscribed in a circle? That opposite angles are supplementary. So if we take X plus 70 degrees, we'll set that equal to 180 degrees, which would give us what? The fact that X would equal 110 degrees. So X has a measure of 110 degrees. Now we can do the same for Y. Y and 80 would be supplementary, so take Y plus 80 degrees, set that equal to 180 degrees, which would just have to give you that Y is equal to 100 degrees. So now we found X and Y. Okay, so we can easily solve for Z now. Let's look at angle X. Again, an inscribed angle in a circle is equal to half the measure of the arc it intercepts. Well, if X is 110, what does that mean? What does that mean then if X is 110? That means the total arc here, since it would intercept the 120 and the Z arc, that means it would have to equal 100. It would have to equal 220 actually. So you would take Z plus 120 degrees. You would then set that equal to 220 degrees. Since double 110 is 220, then you should get that Z, I don't know why I'm putting plus there, Z would have an arc measure of 100 degrees. So then you should end up having that X is 110 degrees, Y is 100 degrees, and then Z, that arc, is also 100 degrees. Alright, we're a third of the way through the exercises. That's a little off kilter. There we go. Another inscribed triangle. This one's 140 degrees. This arc here, this is X. This is 55 degrees. What do we got next? This here is Y degrees. And then we just got to find this one, which is Z degrees. Okay, so we need to solve for a missing angle and then two missing arcs. Well, we'll start with X. X degrees intercepts, it's an inscribed angle that intercepts the 140 degree arc. So that means the inscribed angle, X, would have to equal half of the 140, which means that x would equal 70 degrees. Okay, then we can apply the same for y. The 55-degree inscribed angle intercepts the y-degree arc. Now to solve for the arc, of course, we're going to have to double the inscribed angle, so y would be equal to 2 times 55 degrees, which would give you 110. So y is 110 degrees. And then, of course, it's going to be easy to solve for z. All we got to do is take all these, add them up to 360, we can solve for z. So you'll set up your problem here to solve for z. You'll take z plus that 140 degree arc, plus the value we got for y, which was 110 degrees. Set all that equal to 360 degrees, which would simplify into z plus 250 degrees would be equal to 360, which then means that z is equal to also 110 degrees. So we should have got here x equals 70 degrees, y equals 110 degrees, z equals 110 degrees. We're almost halfway done. We've done 4 of the 9 problems. All right. Let's see. Alright, so we have a circle that has an inscribed triangle with also a tangent line to the circle, and an inscribed angle formed with a tangent line and a chord. Well, let's see here. We should probably still solve for x. So, in order to solve for x, we would need to know the measure of this arc, wouldn't we? Well, this inscribed angle of 50 is, of course, half the measure of this arc. So to find this arc, you would double the 50, and what would you get? This arc would be 100 degrees. So there's a piece of the puzzle. Now, according to that theorem we learned about an inscribed angle formed by a chord and a tangent line, that angle is equal to half the arc it intercepts. So x would be equal to half of 100 degrees, which we know to be 50. So x would actually be 50 degrees then. Okay. So then we have y and z. In this case, I'm going to recommend we go for z first. There's a reason. If we look at this triangle, we have 2 congruent sides, meaning what? It's an isosceles triangle. So both of these angles will have the same measure. So we can actually now solve for z. It's going to come into play so we can solve for y. There's a reason for that. So solving for the isosceles triangle, we'll take z plus 50 degrees, set all that equal to 180 degrees, which then means that you would get 2z is equal to 130 degrees, which means that z is equal to 65 degrees. So we ended up getting that z is 65 degrees. Now if you want to solve for y, this z angle of 65 intercepts the arc with y. To find the arc measure, you just take twice the degree of the inscribed angle. So y would equal 2 times 65 degrees, which of course would give you 130 degrees. So the answers you should have got were x equals 50 degrees, y equals 130 degrees, and z equals 65 degrees. And now we're over halfway done with the exercises. There's only 4 more left. All right. Another good one. Alright, this one I know looks hideous, but I promise you it's actually not going to be that bad. Because you see you have a circle here split into 2 semicircles. Why don't we start with y first, okay? What do we know about an angle inscribed in a semicircle? That it's a right angle. So y is going to be 90 degrees. That one was easy. We found y. So what about x and z? Well, let's start with x. If you look at x, it's another angle inscribed in a semicircle. So what does that mean? It's also a 90-degree angle. And then there's 2 ways we can look at z. Z also is an angle inscribed in a semicircle, which would give you 90. But there's another corollary that comes into play, that if you have 2 angles that intercept the same arc, they're congruent. So either way, you'll get z equals 90. So what you should have gotten was all 3 angles are equal to 90 degrees. All right, 3 more. Home stretch here coming up. Yeah, I guess. I know that looks a little weird and lopsided, but that's what it is. Alright, so this is x degrees. This is 76 degrees. That's congruent. That's congruent. This arc is y degrees. This inscribed angle here is going to be z degrees. Alright, so we have a quadrilateral inscribed in a circle with a tangent line at the bottom. It's definitely going to be easy to solve for x first. So, if we want to solve for x, what do we know about quadrilaterals inscribed in a circle? Opposite angles are supplementary. So that means we're going to take x plus 76 degrees, set that equal to 180 degrees, which would then have to mean that x is equal to 104 degrees. Easy enough for x, right? X is 104 degrees. Now you're looking at this and you're probably wondering, how in the heck are we going to solve for y and z? Remember our best friend auxiliary lines. Yes, you want to draw an auxiliary line. Do it in such a way that it bisects angle x. Now, you have here two 52-degree angles. This would be 52 degrees. This would be 52 degrees. Because you have bisected angle x, half of 104, of course, is 52. Now, if we look here at this inscribed angle, the 52-degree angle down here, it perfectly intercepts the y degree arc, doesn't it? To find the arc, you're going to take double the inscribed angle. So y is going to be equal to 2 times 52 degrees, which would give you that y is equal to 104 degrees. And then we have an inscribed angle here for z degrees formed by this chord and this tangent line. Well, this inscribed angle intercepts the y degree arc, which means it's equal to half. Z is going to be equal to half of the 104 degree arc, which means that z would have a measure of 52 degrees. So what you should have gotten was x equals 104, y also equals 104, then z equals 52 degrees. So remember, it is permissible to draw auxiliary lines when you need it, because otherwise you would have a lot of overlapping arc lengths and there would be no other way to solve it. So feel free to draw auxiliary lines whenever you need to. Two more. We're almost there. Of course, draw the foundational circle. What do we got here? Probably not the best scale model of this, but it'll do the job. Alright, then we have a tangent line running through here. We're even given that these three sides are congruent. This is x degrees. We're trying to find that. This angle here would be y degrees. This arc is 80 degrees. Then this angle here is going to be z degrees. Alright, so we have another quadrilateral split into two triangles inscribed in a circle with a tangent line. So what we have to know here, in this case, the quadrilateral rule doesn't as much apply. Let me explain. If you remember yesterday's lesson when we talked about arcs and chords, we have three congruent chords, right? So what does that mean? That means then if you have congruent chords, the arcs they intercept are also congruent. So in that case, if they're congruent, that means x would also equal 80 degrees. So that's 80. This would also be 80. Then we'll fill in that missing part. So then y should be real easy to solve because it's an inscribed angle here that intercepts the x degree arc. And we know an inscribed angle is equal to half the measure of the arc it intercepts. So y would be equal to half of 80 degrees, which means y is equal to 40 degrees. And then to solve for z, first we need to find this missing arc, right? If we have 80 plus 80 plus 80, what does that give us? 240, doesn't it? Well, if you take 360 minus 240, you would get that this missing arc here is 120 degrees. So suddenly solving for z just became real easy, because whenever you have an inscribed angle formed by a chord and a tangent line, it's equal to half of the measure of the arc it intercepts. So z would be equal to half of 120 degrees, which would have to mean then that z equals 60 degrees. So what you should have got was x equals 80 degrees, y equals 40 degrees, and then z equals 60 degrees. And there's one more. We're done then after that. Just one more. All right, what do we got here? Looking right at it, I still couldn't draw it straight. Good grief. All right. We're even given that these two lines or these two chords are parallel. This is 90 degrees here, this arc. Oh, I almost forgot a critical piece. That there's a tangent line right through here. There we go. This arc is 100. I know it's slightly misrepresented. This is x degrees. This is y degrees. This here is going to be z degrees. Okay, so we have a fun one here. We have inscribed angles, and then we have two chords that are parallel to each other. We still have to solve for some missing angles. Well, it might actually help us here since we do know what? We know one arc measure for sure. This angle here inscribed intercepts the 100-degree arc. So what does that mean? That only means then that it's not central, inscribed angle would have to be what? 50 degrees. So we found a 50-degree angle here. Now we have two parallel chords. Then we have a transversal between them. What do we know about parallel lines and alternate interior angles? That they're congruent. So this is going way back. So x would have to have a measure of 50 degrees. Simple enough, right? Okay, so we got x, that's easy. And then that x degree angle 50 intercepts the y degree arc. And of course, to find the arc, you have to take twice the inscribed angle. So y would be equal to 2 times 50 degrees, which would mean what? That y is equal to 100 degrees. So far we're doing good. Now, before we can even attempt to solve for z degrees, what do we need to find? This arc here. So, let's see. If you add up these arcs, this is 100 degrees, this is 90 degrees, so you have 190. Y is also 100, that'd be 290. If you take 290 away from 360, you would get that this arc is 70 degrees. Alright, so we found the final arc. Z is the inscribed angle that intercepts that arc due to a tangent line in this chord here. What do we know about that? When you have an angle like that, that is equal to half of the arc it intercepts. So Z would be equal to half of 70 degrees, which means what? Z is equal to 35 degrees. So in the end, you should get that x equals 50 degrees, y equals 100 degrees, and then z equals 35 degrees. So that's it for this lesson. Next lesson, we're going to get into other types of angles and circles. We have about 2 more lessons left with circles. I'm sure to everyone's relief, but I hope everyone has a great day. Take care.